Hi everybody, this is still Unit 2. This is your 5th video. I just wanted to remind you of a couple of things before we start bonding chemicals together later this week. We studied the octet rule, so in order to feel stable, atoms will try to bond to gain or lose electrons so that they have 8 electrons paired up in their outer orbital, their valence shell orbital. So generally they will do this when they're sharing electrons or losing electrons, or for those middle metals, they would pool electrons. So the easiest way to show this is what we used in class, the Lewis dot model. Ionic bonds, remember, are when one electron, we called it the little kid, loses its electron to another atom, in this case the big kid, and the atom that has lost the electron will become slightly positive, making it a positive ion, and the atom that has gained the electron will become slightly negative, making it a negative ion. So in the case of table salt here, this would be an ionic bond. And this will chemically alter the two substances that you have. So the two substances in a reaction are called the reactants. So you're going to need that for writing your lab. And the reactants have their own chemical properties individually. So we talked about sodium is very reactive, kind of a silver shiny metal. Chlorine is a toxic gas. And then when you put them together, that loss of electron does not change the nuclei of the two atoms, but it does completely change the chemical properties of the product. So this salt would be called the product. Reactants, product. So in this case, the product, sodium chloride, is a neutral atom, neutral molecule, apologies, and it's not going to react the way that sodium did, and it's not going to react the way that chlorine did. It's now going to react as its own special molecule. This molecule is also a compound, two different kinds of atoms. All right, so this one, salt, is now no longer toxic, no longer explosive, and we eat it all the time. Here's just a little picture. This is a video in the slides. If you want to go to your notes on Google Classroom and watch this, I think if you press this, it should go on your slides. It won't go here. If you press this, you can do whatever you want. It's not going to go because I'm videoing my screen. But if you do want to watch this, it's kind of just exactly what I just said, but it's a little bit more visual. The other atoms bonding that we talked about are the metallic bonds. So these are just pooling electrons. So again, we did lithium, and somebody mentioned it's our lithium party. So this is a silver party, Ag silver. So if you were to look at a whole bunch of silver atoms together in a metal, they're not actually bonded, they're just pooled, and the atom's electrons will actually flow from one down to the other, down to another, loop around all the way through, and that is why metals are able to conduct electricity. The last kind of bond that we talked about were our covalent bonds. These are when they're both big kids or both little kids. So we've got little kid hydrogen here, big kid chlorine here. Neither one is big enough or strong enough, electronegatively strong enough to pull away the electrons. So they end up kind of doing a little tug of war and just sharing their electrons back and forth. So those are examples of two molecules. These are not compounds because this is both hydrogen and these are both chlorines, and they're sharing their electrons. Quick example of different elements, molecules, and compounds. So hydrogen gas, oxygen gas, nitrogen gas, chlorine gas. These are all molecules. Nitrogen oxide, water, nitrogen dioxide, carbon dioxide, these are all compounds and molecules. There are a couple of videos in the notes, so like when you go through, you'll see these little videos. We're actually going to be watching those as Edpuzzles in class and also for homework, so you don't have to watch those now. And I just wanted to take this minute to talk about polar bonds versus nonpolar bonds. So you may have already read these and defined them. They are both vocabulary words. Basically, it's when you have a molecule and it doesn't quite form two complete ions, but you end up pulling some of the electric charge from one electron to the opposite side, and the result is that a molecule would have a tiny positive side and a tiny negative side. The best and most famous example is water. So when we look at our periodic table, if you find hydrogen on your periodic table, it's very small, but it only has one proton and one electron. So even though it's very, very small, it's perfectly balanced. And that one proton in the nucleus, since it's so close to that one electron, pulls on that one electron very hard. So hydrogen is kind of like helium. It's a little bit of a freak on the periodic table. We would expect it to want to get rid of that one electron. But if you think about it, if it got rid of that one electron, it would just be a proton floating around. It would actually be a radioactive particle. It wouldn't even be an atom anymore. So hydrogen holds on to that electron as hard as it can. So you get this capability of hydrogen to bond with much bigger atoms like oxygen, like nitrogen, like phosphorus, like carbon. And it will make a special kind of bond called a hydrogen bond, where it kind of lets go of its electron, but doesn't fully let go of its electron. The result of that and other ionic bonds are that we get polar molecules that end up having a slightly positive and slightly negative side. So this would be an example of a polar molecule. We have a tiny little hydrogen here who's going to hang on for dear life to his little electron. And then we have this big, huge chlorine over here that's kind of pulling that electron. So hydrogen's not completely letting go of his electron, but he's kind of like letting it drift over here a little bit. So that results in chlorine being a slightly negative ion, and it results in hydrogen, this half of hydrogen over here, being kind of positive. So the result is that we have a molecule, a compound in this case, compound molecule, where one half is a little bit positive and the other half is a little bit negative. So this would be very reactive as a chemical molecule. So the whole molecule of HCl in this case is going to react together. This is actually hydrochloric acid. The other option is if you go back here, nonpolar molecules, they don't do this. So like our oxygen molecule we drew in class, it's totally even. It's not positive, it's not negative. So this would be a neutral molecule, not going to be quite as reactive as the others. Okay, so what we're going to do when we come into class is we're going to talk about the law of conservation of mass. We should be doing this in class on Monday. So this is just a quick little review of what we did in class, hopefully on Monday. I'm recording this on Saturday, so it might be a little bit off, but we're going to look at how to chemically write the atoms, and we're going to look at how matter cannot be destroyed. So if we were to mix methane, CH4 is methane, so the black one's carbon, the gray ones are hydrogen, with 2 molecules of O2. So you'll notice this is written exactly as we did it in class. The coefficient is how many molecules we have, and the 2 subscript is how many atoms are in each molecule. If we react them, they may trade partners. So like the hydrogen on this might hop over to an oxygen, the oxygen here might hop over to the carbon, and we might end up getting different products, but the amount of atoms that we had can never change. So, and we'll probably do this example in class just so that it's super clear, and this is an extra reminder. So we started with 4 oxygens, 2 times 2, or you could actually visually look at it and count it up, 1, 2, 3, 4. So when we do this reaction on the product side, we're still going to have 1, 2, 3, 4. We started with 1 carbon over here, we're still going to have 1 carbon over here. We started with 4 hydrogens over here, we're still going to have 1, 2, 3, 4 hydrogens over here. So this is showing conservation of mass, conservation of matter. They are the same law. So we will start balancing equations in class on Monday, and you can watch this video just as a little refresher Monday night, and hopefully on Tuesday we will be mixing some chemicals. Thank you guys for watching.